All right, here's the homework help video for multiplying monomials. So multiplication rules for exponents, basically. Multiplication rules for exponents. Okay, so this is just a little worksheet that I made and we're gonna use. Here we go. No, I don't even think I made it. Okay, it's pretty old, I can't remember. Here we go. I'm going to just work a couple random problems, one of each type. So this top section right here says simplify. We're gonna use one multiplication of exponents rule for each problem. So only one rule will apply. So you're gonna need to have your rules handy. Did you watch the rules video? You're gonna need to have that handy. Here we go. I'm gonna do problem 1 for you, and then you can do problem 3 because it's very similar. So just, I'll do problem 1, you pause the video, you try number 3. Okay, so here we go. N squared times n squared times n. Now, do you really feel like expanding all of it out? Probably not. So let's find which rule it looks more like. I've got same base times same base times same base, and each base has one exponent, no more. So which rule does that look like? That's going to look like this one with the 2 exponents that I could circle. Nope, can't circle 2 exponents. This one with the parentheses. Nope, no parentheses. So it must be the addition rule. Same base times same base. We're going to use rule 1, which says, what do we do with our exponents? Add them up. What exponent is on this base right here? A 1. All right. So 1s are generally invisible as exponents, and they're also invisible as coefficients, okay? You can always add it in, though, and make your life easier. What is 2 plus 2 plus 1? N to the 2 plus 2 plus 1 power. What does it equal? N to the 5th power, okay? Once again, if you really feel a need to expand this out, bring down your times. Expand this out, bring down your times. And expand this out, 1, 2, 3, 4, 5 powers of n are being multiplied. Okay, that's how we get that. Pause the video, try number 3. Let's look at problem 2. Okay, let's look at problem 2. What can I do here with problem 2? Do you see these two right here? Okay, what rule does that look like? What rule does that look like? Does this look like addition rule where I got same base times same? Nope, there's only one base. I have one base, I have parentheses, and I can circle 2 exponents right next to each other. This is looking a lot like the piggyback rule. What are we gonna do with this 3 and this 5? We're going to multiply our exponents. So in fact, from now on, I want you to write which rule you're using. That'll be rule 2. Okay, this right here was rule 1. We used rule 1 on this problem. Okay, here rule 2, multiply 2 to the 15th power. Okay, if you need to see the work, 2 to 3 times 5 is what we're doing. That's the rule we applied. That is the answer, 2 to the 15th. Okay, next, let's use, I'll do this one. I'll do this one for you. Okay, so once again, after you do this, you can pause the video and try number 5. Number 5, is this a monomial? So just use the same rule we applied for problem 2. Okay, so pause the video after number 2, try number 5. All right, let's move on to number 6. Number 6 and number 4 are the same. Okay, so after I finish example 6, pause the video, try number 4. Here we go. This is like which rule? I've got parentheses and I've got how many bases inside the parentheses? Multiple bases. There are 2 bases inside these parentheses. So this is most like example what? I need parentheses, no parentheses here. Here's parentheses, but only one base. Here's parentheses with more than one base. And what did we do? Sharing is caring. And be careful with those negatives. They stay inside the parentheses. So we're going to have -5 stays inside parentheses and gets a 2. And x gets a 2. Now you're going to type that in your calculator and see what you get. -5 times -5 is positive 25x squared. When you're done with your problem, you can get rid of all of your little dots again. Squish everything together. Okay? So now you're ready to try number 4. Pause the video, try number 4. This was rule 3. Okay. Now, what if we have to use a combination of rules? What order do we do these problems if we have to use a combination of rules? Which rules get applied first? How do we decide what to do? Let's look into it. All right, I'm going to do problem 6, and you can do 9. I'll do 7, and you can do 10. And then we'll look down here for the more complicated problems. So problem 6. The first thing we want to do, anytime we're simplifying anything in a math class, we tend to always look at the parentheses first. We tend to always look at the parentheses first. So we're going to do sharing is caring. Everybody gets, this is rule 3. Everybody gets to use that 4. We are doing the sharing is caring rule. Okay, so 9 to the 4th power times m to the 3rd. And if I put a 4th power on that, it's going to look like 34. So you need to separate those with parentheses of its own. Okay, separate the 3 from the 4 by using parentheses. And then n also gets a 4. So even if they already have an exponent, even if this base already has an exponent, you still give them a 4. Everybody gets a 4. Once you've done with the sharing is caring, rule number 3, now what do you see? You have an opportunity to use which rule now? Which rule is that? Which rule was that? I believe that was rule number 2. And that rule is the piggyback rule. And what do we do with piggyback exponents? We multiply, okay? So you can multiply that 3 by that 4, and then why not, let's clean up this 2. What is 9 to the 4th power? 9 to the 4th power. Okay, so you can finish that problem by yourself. Moving on. You can finish that, and then you can do number 7 as well. All right, let's look at problem number 7, okay? And then you can do 10 by yourself. What rule are we going to use on this? I see parentheses again, and I see an exponent on the outside. Same situation. Now, you might be a little bit scared off by the fact that this exponent is a rational exponent, but that does not matter. Fractions are numbers too. Just do the same thing you would normally do. So sharing is caring is step 1. We are using rule 3 first again. You'll start seeing a pattern in how these rules get used. Okay, so 25, the base of 25, how many bases do we have? 1, 2, 3. We got to do this 3 times. 25 gets an exponent of 1/2. X to the 6th gets an exponent of 1/2. Y squared gets an exponent of 1/2. Everybody gets an exponent of 1/2. Okay? And from there, we apply our stuff. You can type this into your calculator, and you'll get what? 5. What do we do with our side-by-side exponents that we can circle? What do we do with those? We multiply them. So what is 6 times 1/2 or half of 6? Okay, and then you do the same with the 2 times the 1/2, and you just get 1 power of y. You can put the 1 or not put the 1. but it won't be there in multiple choice assessments and things like that. So get used to not seeing it. Okay, so now you're ready for 9 and 10, problems 9 and 10. Pause the video, get them done. All right, now the second half of this. I've given everybody my pre-AP challenge questions. You see them on the bottom? Don't look at them yet. You'll just get scared away, okay? So let's look at how to ease ourselves into these ugly problems. Let's try, I'll do 2 of these for you. They're about the same. Let's do 11 and 14. Then you'll be on your own for 12 and 13. And of course, the challenge questions. Okay, so for number 11, step 1, we generally take care of parentheses first. So let's do that. What rule involves us taking care of this 5 outside of these parentheses, this 5th power outside of these parentheses? That is the sharing is caring rule. That is, once again, rule 3. So everybody, all 3 bases, get a 5. Okay, get a 5th power. So 3 to the 5th power. A squared to the 5th power. B to the 3rd to the 5th power. And then don't forget, we have this and this still as part of our problem. Next, we're going to multiply out what we can. I guess we could do that at the end. Okay, what are we going to do with these side by sides right here? What are we going to do with those? We're going to use rule 2 for those. So next is rule 2. That's the piggyback rule. So once again, we've got 3 to the 5th. What do we do with those? We multiply them. So a to the 10th power. That's a 5. A to the 10th power and b to the 15th power. And don't forget about this guy. You're like, what's he doing? Nothing, but keep bringing him down. Now, what rule have I not used? I've used rule 3. I've used rule 2. What's rule 1? We sometimes forget about rule 1 because it's so simple. Forget about the simple stuff. That's when I have same base times same base. And what do I do with that? I add my exponents. Keep the base the same and add the exponents. So do I have same base times same base in here somewhere? Yes, I do. So what are we going to do with these exponents? We're going to add them together. Okay, so that is going to be our very last step using rule 1. Notice what order these rules get used in. That is not a coincidence. Okay, so aside from adding these together, I am also going to go ahead and take care of my 3 to the 5th power. 3, remember where your exponent key is other than squared? It's this one right here. 3 to the 5th power. Okay, so once again, this right here allows me to raise to any power. 3 to the 5th power equals 243. I knew that. Okay, here we go. So 243, the a to the 10th is still there, and b, add your powers to the 17th. Okay, so if you understood that, pause the video and try problem 12. It'll be very, very similar. You know what, I've just changed my mind. I said I was going to do problem 14. I changed my mind. I'm going to do problem 13 instead. The reason being, I want you to see what happens when we've got coefficients in the mix. Okay? So anyway, you know what to do. And by the way, that's kind of a challenge question. Very similar to question number 5 up here. I don't know. I might offer extra credit if you guys figure those out. Okay, problem 13 then, since I've changed my mind. Let's do what we do. Head toward the parentheses. That's usually where we start cleanup. So, sharing is caring. 2 bases inside of the parentheses. Which rule is sharing is caring? It's rule 3. Everybody gets a 4. 2 to the 4th times d to the 5th to the 4th. Remember, you don't want it to look like 54. That's where those parentheses come in handy. Then bring this down. Bring these down. And why don't you separate those with dots just to simplify your life? Dot 6. Okay, so now every term has a dot between every term, so you don't get confused on how to deal with anything. All right, now I'm going to clean up what I can clean up. Let's apply another rule. We used rule 3. Ooh, I think I can circle 2 exponents. What rule does that call for? That calls for rule 2. Okay, so we're doing a piggyback rule right here. Let's multiply those. Times d squared times 2 to the 4th times d to the 20th. Okay, we've applied rule 2. Now, let's rearrange our terms so that we have numbers with numbers, variables with variables. Remember, multiplication is commutative, which means switchable. Okay, so let's rearrange for a second. Let's do our 6 times our 2 to the 4th power together, and our d squared and our d to the 20th together. Now, do you see another rule that we could use here? I see same base times same base. So because I see that, what rule am I going to apply here? Rule 1. What are we going to do with these two exponents? We're going to keep the base, add the exponents. Also, we're going to type this into our calculator and clean that up as well. Go ahead and finish that problem by yourself. Well, let me help you, just so you can see. I'm literally going to type what I see. 6 times 2 to the 4th power. What do we end up with? 96. I want you to type it exactly as you see it, okay? All right, so we're going to have 96 d to the 22nd. That's going to be my answer. 96 d to the 22nd. That will be the answer for number 13. Okay, so that's how we do it when we've got numbers and variables all mixed together. We've got 2 different types of bases to work with, and this is how you handle it. Rearrange, because multiplication is commutative, and by that I mean switchable. Okay, good luck on your homework.